So welcome to my talk. So I want to talk about advanced dependency management today. So we'll not talk about like how to declare a repository or how to declare a dependency by itself. We'll actually drill into more real-world kind of scenarios. And some of these scenarios are taken out of engagements that we had together with clients. So we'll certainly see how we solve certain problems with the help of the deep API that Gradle has that Hans already alluded to this morning. My name is Ben Mushko. I work for Gradle Inc. And you can see we have the elephant here as well now. I'm working as a Gradle core engineer, but these days I'm also helping a lot of clients go inside, deal with their dependency management issues, their migrations, and all these kinds of things. So why do we even need kind of like a way to model more complex kind of builds? That's kind of like the fact. If you look at big enterprises, they have specific requirements that go beyond just declaring repositories or dependencies. Typical scenarios could be you want to use dependency management, but you don't want to use transitive dependency management. Could be one scenario. You want to be under full control over what you do. You just want to declare them yourself. Could be one scenario. Gradle allows you to do that. Other scenarios could be you depend on a specific module, but you know that that module somewhere deployed, let's say in Maven Central, is broken. So you want to say automatically when somebody depends on that specific version of the dependency, simply use a different version of that dependency, just to make sure that things are not broken, things are not being pulled in automatically. Sometimes you want to modify the metadata of modules that you actually resolve. So after you resolve these specific artifacts, simply do something with the metadata, modify it to your needs. And there are some other scenarios. For example, you want to actually have access to the raw artifacts once you resolved it. They're in the cache already, but you want to do something with it. That's some of the questions we see on the Gradle forum. And we have ways to solve that. If you look at Maven or other build tools, it might be much harder. But Gradle allows you to do that. How do we allow this to happen? So you might know that we have a fairly deep model in Gradle. So whenever you start your build, Gradle will configure that build and then create the specific domain model objects in memory. And what you can do in your build, you can also access these objects. And one of these objects is a dependency handler. So whenever you deal with dependency management, that's the guy you want to usually go for. The other domain model object could be a configuration. So we'll see a bunch of examples where we actually do that. Some of the things we want to talk about today are especially these rules that Hans mentioned this morning. So there are dependency resolve rules. So you can say whenever I resolve a version, simply tweak this in a way that it uses a different version because we know it's bad, or we standardize on a specific version. Could be one of the scenarios. Or you want to do something with the metadata. These are the component metadata rules. Or you can say, whenever I select a specific component of a resolved module, then do something else. That could mean, for example, reject that artifact. So we want to, for example, standardize in an enterprise that people are not allowed to use a specific module. Let's say you want to depend on Ivy, though you're using Gradle. We could easily say on an enterprise level, we will not allow this. This could be part of a Gradle distribution, this piece of code, and then you can basically standardize with the help of these dependency management rules. One of the newer APIs that we have in place is the artifact query API. So that's the API that allows you to access the artifacts after they have been resolved, after they have been put into the Gradle cache. And we'll talk about this a little bit later. So I'll have an example where we actually have a look at a resolved pom.xml. We actually read the file and we get something out of the pom.xml if you ever need that. And we'll also have a look at a more complex example where we actually build a offline repository. That's something that many people ask for on the forum. Once you build, like you have your Gradle cache, but you also want to have a copy of that cache somewhere else for specific reasons. Before I actually want to drill into these dependency resolve rules and all these other rules that we have in place, I want to take a step back. I want to talk about the Gradle dependency cache a little bit deeper, and I think there's certainly the need to improve the documentation on the user guide as well. So we want to let people more understand or deeper, give people a deeper understanding of what the Gradle cache looks like, what the performance features are, what the general features are, and how we store these artifacts. Because sometimes people simply say, I'm coming from Maven, I know where they are, but in Gradle that looks kind of different and it changes across versions, and I don't know why we do this. So there are specific reasons why we do this. So we want to enable ourselves to improve performance when we resolve artifacts. We want to make sure that the artifacts that we actually resolve are from a specific location. And as we change the list of repositories, we want to also ensure that what we already have in the cache is actually what we resolve from the correct repository. And generally speaking, we want to be efficient. Don't try to make as many HTTP calls as you can. We actually want to minimize that. So also on the level of dependency management, we want to improve performance. By the way, if you have any questions, feel free to ask if they are kind of contextual. Otherwise, we can talk about deeper questions, maybe from your project at the end of the session. So typical scenario. So I tried to point out specific scenarios, and then I tried to show you how we can solve that specific scenario or why things happen in a certain kind of way. Back to the cache. So some people report that they set up their Gradle project. It works with, let's say, 2.2.1. And at some point of time, they upgrade to 2.4. They already resolved all the artifacts that they need for their project. But then what happens, all of a sudden, people say, well, we re-download the internet. I don't know why this happened. I have no idea. Something must be wrong with Gradle, I guess. But there's actually a good reason why we do this. And the reason for that is, again, because of these features that we want to implement over time, we want to have a specific layout of the cache that we version, that we can change over time. Just a set structure wouldn't work for that kind of purpose. So that's the main reason why you potentially have to re-download specific artifacts. So let's have a look at the actual structure here. So some people might look for the Gradle cache. You can find it in your user home directory .gradle/caches. If you completely wipe that out, like all your artifacts are gone, you have to re-resolve everything. But you can see that we also have specific subdirectories here. So we find modules 2 that's specific to a specific Gradle version. That could be modules 3 or 4 or 5 or something else in the future. That's basically the root directory where we store all the artifacts for a specific Gradle version. And then we differentiate between the files. These are the resolved artifacts like the jar files and so on, maybe some checksum files and so on. And we have the metadata subdirectory. And the metadata subdirectory pretty much stores whatever we have in terms of the pom.xml or ivxml. You might have noticed that we actually model this into an ivxml if you had a deeper look. So it's actually not a pom.xml anymore when you resolved it from Maven Central, or generally speaking, a Maven repository. We actually store this stuff in an ivxml. That's for historic reasons that might change in the future. So let's talk about some of these features that we want to improve on, and some of them are already there, of course. Lazy downloading of binary artifacts. So what we do is that we try to prevent the dependency management handler to actually download artifacts that we don't need for this current operation. So if you run Gradle, let's say Gradle tasks, and you don't run any other specific task, then we kind of know that nothing else needs to be resolved. We don't actually need the artifacts, for example, for compilation or for any of our tasks that require dependencies or artifacts. Only if we actually do something with it, if it's an input for a specific task, then we actually download the artifacts. You might have noticed that if you run a build, if you run Gradle tasks, nothing is downloaded, but if you run let's say Gradle compile Java, all the compile time dependencies are resolved. I don't think I need to speak more about the cache in general, how it works under the covers. So whenever you resolve from the remote repository, we actually put it into the local cache. I forgot to mention that in the beginning. We also use the checksum, which you might see on Maven Central or other repositories to actually see if we already have the corresponding artifact in the local cache. If we have that, then don't even try to resolve the remote artifact. We try to minimize the number of HTTP calls. So instead of using snapshots, we now want to use dynamic versions. So in this case, we go back to the hello world example. Pretty simple. That's the producer. And instead of using the snapshot version, we now say we want to use the version 1.0.1. So that's the concrete version that we actually publish to a release repository on Artifactory. And that doesn't look different. We still use the Maven plugin. All right, we find this in a different repo now. And in this case, you actually don't find timestamped versions. You actually find the concrete version. If you go back to the consumer, we now say 1.0.plus. So give me the latest version of that series of versions. Okay, so let's say Gradle dependencies, and boom, Gradle actually tells us what version was resolved. So 1.0.plus resolves to 1.0.1. That's the only version we currently have on Artifactory. Nothing too special about it. But let's now change the code again. So we want to say hello Gradle. And we want to bump up the version in our produced artifact. So instead of like 1.0.1, we want to say 1.0.2. Publish that guy. And again, what do we expect? It's going to be cached. So it's right here next to the 1.0.1 version. And then we go back to the consumer, run Gradle run again. And we find ourselves still having the same version or dependencies. So we're still pinning down to that one. So let's actually change that code to also adapt to it. So again, you access the configuration handler, which knows about all of your configurations in your build. Oftentimes, it actually makes sense to use the all kind of functionality because you don't want to type it out for each of the specific configurations. And now the method that we actually call on the resolution strategy object that we get back here is cache dynamic versions 4. In this case, we set it back to 0 minutes just to show you that it actually works. We say Gradle dependencies down there, a little bit cut off apparently. And you can see Gradle resolves to 1.0.2 instead. And Gradle run actually gives us hello Gradle now. So all good. What you define here in your own organization in terms of like the numbers is kind of like up to you. If you don't use dynamic versions at all, ever, or snapshot versions, then you're good. You don't actually have to do anything. But that's kind of like where we apply the caching functionality that we have in the cache for Gradle and can simply tweak it to our needs, depending on what your enterprise requirements look like. A bunch more interesting command line options that might come in handy. If you ever find yourself wanting to work offline, you're on the plane or somewhere else, you don't have Wi-Fi. These days, it's actually not happening that often anymore, but you can use that option here, --offline, and if you already have the artifacts in your local cache, Gradle will not check the remote anymore, so you can still build without a connection to any remote repository. Another one that comes in handy is refresh dependencies. So if you want to ensure that you always have the latest stuff, independent of what you said for the time to live that is applied by, let's say, your company plugin, you can always say, hey, check everything. I just want to make sure that I got the latest. Then simply go for this one. This sometimes comes in handy on a CI server. So if you want to ensure that whatever you build on the CI machine, you simply pull up the latest stuff and then you go from there. Okay, so before we get to the rules, I also want to talk about one topic which comes up every so often, debugging dependency resolution failures. How do I approach it? How do I best manage and find out more information about it? So I want to show you some scenarios here. In this case, we say Gradle dependencies, and we want to print out the dependencies that we assign to the compile configuration. So in this case, apparently we depend on common slang. And we also depend on Java XMail. And you can see Gradle tells us that failed. It doesn't actually tell us more about why it failed, what happened under the covers, really. I think it's fair to assume maybe the version wasn't published or something. So if we actually want to find out more information, we can change the logging level. So if you run into issues when trying to resolve dependencies and something goes wrong, try to add the --info or --debug flag that actually goes down to the actual HTTP calls. So in this case, if we look here, resource missing. So apparently the version doesn't exist for the POM file, it doesn't exist for the jar file. And therefore, in the dependency report, we simply say, hey, we can't resolve it, so well, that's too bad for you, you have to fix it somehow. Well, that's one situation. The other situation is that you run the dependency report and it doesn't report any failure, but if you run your compilation task, it fails because it couldn't resolve a dependency for whatever reason. So in this case, we actually changed the version of Java Mail, so we know that version didn't exist in the repo. We actually changed it to 1.3.1 that actually exists on Maven Central. And you can see it also has a transitive dependency here, so the activation library. But if we run compile Java, it tells us, well, we could resolve probably everything except the jar file in this case. So you can see that you can still run into situations where the dependency report looks okay, but a specific artifact cannot be resolved. And why is that? Specifically on Maven Central, you can see here, if you look at Java Mail, they only publish the POM file, but not the jar file, for, I think, license reasons. But keep in mind, in enterprise scenarios, this is something you can easily run into. You might be able to spend like hours on this, just trying to debug how you get along with this. Any questions so far? Otherwise, we'll talk about the rules. Yeah? Okay. How do you publish your module directly to the cache? Oh, yeah. Yeah, you can't. In this case, offline wouldn't help you. You cannot publish something new anymore because you don't have access, internet access to the remote artifactory anymore.
For that use case, can I publish directly into my cache and have the second module?
Oh, I get it.
So like Maven
yep.
install or something.
You could. You just have to like change the URL that you want to publish to userhome/m2/repo or repository. If you wanted to publish to a Maven repo, if you wanted to publish to a local cache, you would have to know the exact path. Because again, remember, the cache is actually opaque. So right now, there's no easy way to do this, except if you give it the full path. No. Whenever you publish to the local Gradle cache. You can publish to M2 repository. That's fine. You could. Can you repeat the question again? Okay. I've never done it, but if that works, you could publish to the Maven local cache, yeah, if you want to. That's usually useful if you have two different projects. Let's say you work on a Maven project, the other one is already migrated to Gradle, and you still want both of them to be able to work together. So that would be kind of like the use case.
The second question, is there any equivalent to, when you do a Maven publish, one of the things that it does is it checks to make sure that you have no snapshot files. Is there any equivalent to that for Gradle?
Can you repeat?
If you're publishing something for a final, I want to make sure that my internal dependencies that I'm publishing have snapshots because those are going to be viewable at the time.
Oh, so I think the question is, can I ensure on a global level that whenever I want to release my artifact, my module, I'm not depending on any snapshot versions anymore because that's considered to be bad. They're currently under development. Please only use the release ones. You could, and we'll actually see an example, not directly to your use case, but you could easily tweak that with the dependency resolve rules, or something that that basically hooks into the publishing API. You could say whenever we depend in the dependency handler on any version that's a snapshot version, fail to build or whatever you want to happen. So that would be possible. Yep.
You gave the example of the offline and refresh dependencies. Is there a granular way to control that? For example, just refresh all my Java libraries and don't refresh like big other examples or big documentation.
Not as far as I know, not at the moment.
Because you can also use the control TTL. It would be possible to control TTL per package or per group or some or whatever.
Mm-hmm. I would have to look at the API. I don't think we can do this at the moment, but if you wanted to contribute, we're always open to new stuff in Gradle. Sounds like a great idea. So if that's your use case, yep. So unfortunately, we're not that flexible yet, but yeah, I mean, that's really, I guess, a very specific case, I guess. Oftentimes, you're probably online anyway.
Yeah, but you may be online with a very traffic.
Okay, fair enough. Yeah. Okay, yeah. So you can see there are certainly other use cases that we could bring up that you could potentially solve with the help of the Gradle API. And sometimes it's just not built out yet. So let's talk about these dependency resolve rules. And I want to give you some examples here. So one example could be people request a specific version of a module, Spring 4, but we want to standardize on a specific version of 3. We don't want to allow our developers to actually use a specific version of a library. We blacklist that one. So you can easily apply one of these resolve rules and say, well, whatever the guy picks, we'll go for that other version. That could be another way here. I mentioned you want to standardize a good version. We want to recommend specific versions, so that's another use case where you say something similar to the Maven bill of materials. So we want to have like a master list of dependencies and specific versions, basically mapping between these. We want to say, hey, developers, you don't actually need to think about this. If you just request this group ID with the specific name, then please resolve to that specific version because we deemed it to be good. It could be another use case. Or in some scenarios, companies were bought out. They used to have an old coordinate, like some org my company, but they are now called something else. And you want to say, hey, we don't want to bother our developers with like having to know that kind of stuff. We simply make that determination for them. So we can define these dependency resolve rules to automatically let this happen. So basically remap the coordinates of a specific module. So how do you make this happen? Again, in this example, we want to enforce a specific artifact version. And we say this should apply to all configurations. Again, we access that resolution strategy. And by doing that, we also have access to a specific method, which is called each dependency. So with that, we can basically iterate over all dependencies that we have declared in our build file. And we can say, if the build script actually requests a specific group, we haven't resolved it yet, then do something with it. And that something, in this case, simply says, use a different version independent of what the guy actually requested. Let's see this in action. So in this case, what we have here, exactly the same example. We have the Spring framework. We have 2 libraries. And the guy, like some developer in your organization simply says, I want version 4.1.6, but you're that like group of people, that tooling team that doesn't want to allow this thing to happen. So we want to say, check first, make sure that these rules don't kick in yet. So apparently I didn't have it in the cache, so we download that specific artifact version, in this case 4.1.6. Dependency report worked here properly. But now we actually want to say we want to remap that specific version So we can, again, access the configurations handler, define this for all dependencies that you declared in your build. We use the resolution strategy and iterate over each of these dependencies. So in this case, we actually have two. Keep in mind, these are the top level dependencies. And the object that we actually get passed in this specific method as a parameter is a dependency resolve details, which basically gives you information about the requested group, the name, the version, and all these kinds of things. And I can say, hey, let's filter just the ones that match the Spring framework, and then we simply want to remap that to a version that we deem to be good. So let's try this out. And again, we run Gradle dependencies for that specific configuration. And you can see the new version is downloaded, and Gradle actually tells us your requested version 4.1.6, but it was remapped to the version that we changed it to. If you as a developer want to find out more about why this actually was chosen for you, apparently, it's always helpful to go for the dependency insight report. Again, in this case, we have to give it a specific configuration and a dependency that we want to inspect. In this case, we want to say, hey, just for the Spring framework, let's say Spring Core, we want to know why this is actually happening. And you can see it basically goes from the resolved dependency up the tree, and Gradle actually tells us a little bit more about it. It was selected by a specific role, which we basically applied in our build script. So that's how you can find out if something is picked for you, why this was actually happening.
Why wouldn't you just fail the build if they were using it?
You could do that, yep.
I mean, why kind of secretly remap it?
It could be something like a soft mode, where we say, hey, we don't want to break people for a while, or we are in some migration phase. You could throw an exception, you could send a message, you could send an email or something else, log it, whatever you need to do. It really depends, again, on your specific requirements and your organization. But yes, if you really want to strictly enforce it, simply throw an exception, boom, and then everybody knows. It has to be kind of like expressive, I would say. People would need to know why you're actually failing the build. So in the message, I would say, like, tell people why you actually did that. Yep.
Can I also change the nature of the dependency? For example, what I like to sometimes do is if I have a multi-module project and I have a use case where I just have the source code for one module checked out, and in that case I want to just resolve as an artifact dependency. But if the source code for the other module is checked out, then I want this to magically transform into a project dependency.
Absolutely possible, and that's something we'll touch on today as well. So pretty much at the end, we'll touch on that. But if we want to go further, either you've seen the talk this morning, where we talked about fluent dependency management, or you come to my next talk, which also has a bunch of more slides about that specific scenario, when you want to switch out a project for a module, or the other way around, what we usually call dependency substitution. We'll talk about this, and will be part of this presentation as well. So, what I wanted to talk about as well is if you wanted to specify basically a mapping between good versions and specific coordinates. I hear this all the time. It's pretty popular in projects. So if I come there, they always bring up like a bill of materials, a parent POM, or something else. So that's all possible, and I want to show you 3 approaches for that. And we kind of we'll build up that example step by step from a fairly simple data structure, like just a plain mapping. So we just built a map in memory to a JSON file in the end. And you can see how easy that actually is. You don't actually have to write so much code. But if you wanted to build things like that, and if you wanted to go further than that, I'll also talk about plugins that are out there in the world. Some people actually wrote plugins that are pretty flexible, so they'll get a shout out a little bit later. But the principle is here, you want to predefine a specific version for a dependency. People don't have to think about it. Maybe it's even the combination of certain dependencies that work together in a certain kind of way. So how could you model this in a Gradle build? So here's one example where we say we want to introduce a magic kind of like identifier for versions. In this case, I just called it default. And whenever a user says, I want the default version of the Spring Core framework, then please hand it to me. I don't want to think about what the good version should be. That's what I do. So let's have a look at the demo, how we can build this out. It's actually pretty simple. So again, same example here. We simply say for the Spring framework, pick the default versions. I hope you can see this. In this case, it's a little bit smaller, I guess. Oops. But I will talk about it, and we'll have more examples that are actually more advanced than this one. So just imagine you're depending on the Spring Core framework here with the default version. I don't want to think about it, just give it to me. And what I did here is actually I created a build source directory. So I actually want to build some build logic which is automatically compiled out of the box. What you find there is a class which is called Dependency Version Recommender. It has a mapping between the group and the artifact ID and the version. And it exposes a method which is called find default version in catalog, which passes in a group and a name. Both are strings. If you can find it in that map, perfect. Simply use that specific version. Otherwise, throw an exception. So we don't want to allow even something to be passed in that is not possible. So if you would say commons lang default, right now it's not in the map, so it would basically fail. So what we need to do here, and probably most of you guys know that, if you set up the build source directory, it's like its own project. You can dump in like build files or other classes that you want Gradle to automatically compile, and they are automatically added to the class path of your build as a jar file. But again, you still have to import the class if you actually want to use it. So that's what we're doing here. So we just import the class, which has been compiled by the build source directory. We create an instance from it, and then again we go to the dependency resolution strategy. In this case, it's actually the configuration. We iterate over each dependency, and then we want to use the instance of the recommender implementation to do this mapping for us. So instead of saying use version, some version, we simply delegate this information, or kind of like the logic that knows how to handle that kind of stuff, to our implementation. So in this case, we actually say if the requested version matches the magic identifier, which is default, resolve the version from our class. So that has the internal knowledge of how to resolve that. And we use that method that we exposed, so it's really nothing special. It's a class with one method and like a field, which is a map. And we pass in the group and the name. In this case, details requested group, details requested name. Or it's probably, sorry, not version, should be name, yep. And then we simply use the method that we already know, use version on the details instance that's passed in here. And that's pretty much how you can implement that. So it's actually fairly simple if you want to have a low-level implementation. So we go ahead now, Gradle dependencies for our specific configuration. You can see that build source is compiled first, and we can see default now maps to the concrete version that we have in our internal map. So I think that's a good start if you want to implement that kind of stuff for your own project. I think I'm going ahead for me. But what happens if, well, you do this for an enterprise? I mean, usually like a map is probably not well maintainable. Over time it grows, you have to touch a class file, At some point of time, you want to externalize that logic in some sort of form. And that one form could be JSON. It doesn't have to be JSON. It could be XML if you want to. You don't need to. Could also be some HTTP service that you write in your organization, which then you can also edit like online or stuff like that. So it could go totally crazy here. But I want to show you how to make this happen for a JSON file as well. So we can actually add on top of the existing logic here. And in this case, we want to use a JSON file. We still have the default version. We still use the class that we already know. That stayed all the same, but we want to change the implementation of the recommender class. So internally, instead of using a map, we just want to use that JSON file. So it has a field here, default versions, and has a group, a name, and a version for each of your recommended dependencies. So let's hop over to the actual implementation. You can see we only changed it slightly. Down there is a new method now, a private method, which basically uses the Groovy JSON slurper. Really nothing too crazy, but it's a built-in class in the Groovy API. We simply read the JSON file and we traverse the structure, in this case JSON, which is basically the root node there. We go to default versions. We simply find the one that matches whatever we passed in, and the rest looks exactly the same. So pretty easy to externalize that stuff. And I think you could also tweak your own projects to use this logic if you feel the need to have that. Just to verify that this is working, we say Gradle dependencies again, and we say this for the compile configuration. And again, logic looks exactly the same, except that we now read from the JSON file. Keep in mind, the JSON file will be read on every build. So Hans mentioned this morning that at some point of time, even for these dependency resolve rules, we want to apply caching. And that will happen automatically with future versions. Right now, these rules don't have any inputs or something like that, so we can't actually define this. So you had a question, yeah?
Do you have this code available?
I can make it available. It's not part of the slides, but I will upload it after tonight at some point of time to the slide deck. I'm not sure whether you can later on go ahead and get the slides again. I would have to ask that. If not, I will put it on my GitHub account by the end of like tomorrow or so. Yep.
You're going to start caching, but you also have to check whether the file can change and stuff like that.
Exactly. Yep. You could implement your own caching if you wanted to, but hopefully at some point of time it should look as easy as, let's say, incremental build functionality in Gradle. You shouldn't have to like deal with the low-level kind of like caching stuff. What I just showed you, which I actually forgot, that I also add Commons lang in the meantime to the JSON file, dependent on the default version, and we can see it actually works. So we looked it up in the JSON file. Okay, so let's go a little bit crazier. So now we want to say, hey, we want to be so Gradle, nobody else will understand my own language anymore. So we add on top of the Gradle DSL. So we want this to look like something that comes from Gradle, but it's actually our own extension to Gradle. So in this case, you can see we don't use that default identifier anymore. So the knowledge of telling people, use that magic identifier to get the default version, we can externalize into a method, which has type safety and all kinds of other stuff built in. If people mistype default, well, it wouldn't work properly. They don't know why. But here's one example how you could basically extend the default Gradle core DSL with something that you built yourself. In this case, I just introduced a method which is called default version. It should hang off the dependency handler. So let's actually implement that thing to give you an impression how you can make this happen. So we actually started with the example that I just showed you. I'm already using that method, but there's no implementation backing it right now. Everything else works as before, so we use that JSON file, so that should stay the same. We have the recommender class that stays all the same. But what we want to do is that we use that JSON logic to actually extend the Gradle DSL. So just to show you, nothing changed here. That's all the same as before in the other example. But let's now go ahead and actually implement that default version. So where's that guy even coming from? Gradle by default doesn't know anything about it. So what we want to do here again, so we start out by implementing or by importing the specific recommender class. So for this example, I haven't done it yet. So we still need to have that knowledge. And then we say we can actually define another dependencies block. If you wanted to, you can have as many as you want to in your Gradle build. In this case, we want to first create the instance of the recommender class. That's something that's also not new. And keep in mind, you don't actually have to create the instance within the dependency handler. It will be propagated up anyway through a closure delegation. I will actually pull it out. So we create the instance first, but now we're using the extension functionality, the extension API of Gradle. So in this case, you might know that you can create new properties that hang off specific domain objects, for example, a project or something else, a task. But in this case, we actually create a method, and we pull a groovy trick here by saying, instead of defining a method, we actually assign a closure. So don't evaluate it until you don't actually call it. And you can see there are two parameters that look pretty similar again, a group and a name. And we use the recommender class in this case to just pass through this information. So a group, a name here. And these are these two parameters that we actually pass in. If you wanted to have one string, you can, of course, model that. This is more a little bit stronger modeled. And then you can simply say, from the dependency handler, simply create a new dependency, which is a method, which hangs off the dependency handler with these coordinates, and boom, you basically simply assign a new dependency here to the compile configuration. So let's try it out quickly to make sure it's working. And whether you do this kind of stuff or not, again, also this DSL that you built yourself requires some documentation or at least communication. Otherwise, people don't know that it is there. In the long run, we actually want to be able to discover these things. Like there could be some report that tells you, okay, there's a new method that you usually don't know anything about it, but it's now there, and we have a little description. This is what it does, and this is how you use it, stuff like that. So it works fine, awesome. So this is just another way of handling these kinds of recommender implementations. What I want to show you now are two plugins that are helpful if you're kind of lazy, you don't want to build this stuff yourself. So there's one built by the Netflix guys. It's pretty helpful. It's called the Nebula Recommender plugin. And that one is actually fairly flexible. So it allows you to pull information from BOM files out of the Maven world. So if you have something already defined in BOMs, fine, you can reuse it. You can use JSON files that you assign. You can have custom logic. You can have a data structure. So that's fairly flexible here. So if you come up with something yourself, you can still implement that. So I would highly recommend that one here. There's another one built by the Spring Source guys. It's called the Dependency Management plugin. I don't know why they called it that, because it's actually just something very specific. And that guy just resolves the BOM file. Probably because they make the mapping out of the Maven world into the Gradle world. So basically the dependency management block in the XML should apply to Gradle as well. So what I want to talk about next is one of these component metadata rules. So they are slightly different than the resolve rules. In the case that you already resolved a specific module and its descriptor, but you want to do something with it. You might want to read it. You might want to change that metadata on the fly as you resolve it. Certainly helpful, especially if you want to be highly flexible. Especially if you're coming from Maven, you might feel the need to introduce your own statuses, and that status should be changing. And when I talk about changing again, that's basically considered to be a snapshot, a cached version for 24 hours. But don't use the integration status. We want to look like Maven. For whatever reason, you can do that. So you can publish your artifacts with the snapshot status, which is not standard Ivy, but still tell Gradle to handle it in the same kind of way as the integration status. And this is one example here. We have Ivy repo just in the file system in this case. And you can see the published metadata has the snapshot status. And what you can do with this now, if you model it correctly at Gradle, you can actually pull tricks like saying, give me the latest snapshot version. And you might know by default, Gradle says latest integration, which is the default status in the Ivy world. But now we want to inject our own logic here somehow. We want to define how this behaves. And that should behave exactly like the latest .integration. This is something that you can make happen. And you can make this happen with this kind of notation. So instead of like going from the configurations, we actually go from the dependencies handler. And you can iterate over all components, and that component basically resembles like a resolved artifact, which has certain details. And these details basically contain the metadata that you just resolved for your artifact. So let's have a look at that. So I want to show you one example where you can actually remap integration into something else, like snapshot. So emulate the snapshot status in the Ivy world with the help of Gradle. So again, we have a producer, we have a consumer. The producer publishes a version 1.0 dash and then the current timestamp. And you can see we use the new publishing API now on the plugin, which allows us to set the status as we publish it. So in this case, the status we map to snapshot, something that Gradle usually doesn't know anything about, or Ivy even. So let's go ahead and publish that. Instead of calling upload archives, we say publish. That publish to a local repository on the file system, which we now find here, just adjacent to the consumer and the producer. Don't want to make this round trip anymore to Artifactory. If you would have a look at the metadata, you would find that the status is snapshot. Now what we want to say is, give me the latest snapshot version from this local repo that I just published to. So if you just run this stuff, what would you expect would happen? Any ideas? Okay, let's try it out. So right now, it doesn't know anything about snapshot, really. It simply says failed. Again, if you wanted to have more information about why it failed, -I or the insight report. But let's actually equip Gradle with the information that we need to remap that status. So we want to say whenever you encounter the snapshot status for any of the resolved metadata, then please mark this as a changing artifact. And also, we have to tell Gradle what the list of status schemes looks like. By default, that's dev, integration, release. But in our case, we are some special enterprise organization. We want to have something else like dev or in snapshot and release. So that's what we want to do here. So you can see we check the status. So if the status matches snapshot, that's what we published. Then mark this guy as changing. So that's one of the methods that is exposed over that component metadata details object. And then we also have to give Gradle the knowledge of which statuses actually exist. In this case, we say snapshot and just release. So if you run this now, everything should be fine. And if you say Gradle dependencies, it should resolve to the latest snapshot version, which now maps to that concrete version there. That's the one we just published, 1.0 and the timestamp. So there are a bunch of other rules that I want to cover, not that deeply anymore, but I just want to talk about them. So one of these other rules that you can apply in your build script is a component selection rule. And you can see that looks slightly different, but kind of familiar. So again, we go off all configurations, use the resolution strategy, and we say, of the selected candidates in our build script, we want to reject certain dependencies. So in case, that's pretty much exactly the case that you mentioned before. Instead of using dependency resolve rules, we actually use these selection rules. We actually want to throw an exception here. This is like the typical use case for Guava, which used to have a different group ID than it has now. And we just want to say, whenever a developer uses the old coordinates, simply fail the build, reject that specific dependency. And you can make this happen with these rules. So in this case, I actually depend on both of them. So the old one and the new one. If we run Gradle dependencies, Gradle will be happy. It will pull in both. It doesn't really care. It doesn't really have the knowledge that they are kind of similar things, but not really. You can see both of them are resolved. They don't have a transitive dependency right now. And now we want to go ahead again, configurations all. Give me the resolution strategy. And request the component selection. And for all of these selections, do something. Again, this might look a little bit unfamiliar. If you want to know more about that kind of stuff, I always recommend going to the user guide, finding out how you can define this stuff. The dependency management chapter in the user guide actually grew quite a bit over the past, I would say, 2 years. And now we want to say, if you encounter the collections group and that specific artifact ID, so in this case, we actually call it the module. So in the long run, we will call many things a module instead of a artifact ID or name, just to keep that in the back of your mind. And if that matches, then simply reject it. And it's fairly easy to traverse the API. So you just go off the component selection, and then you look what methods do you have there. Then you go one level deeper. What does that guy return? And then you know exactly that the reject method hangs off the component selection. In this case, we want to give it a really nice message here, a nice description of what's going on. So we just want to say the dependency with these coordinates is deprecated. We want you to use something else. So certainly this serves as documentation in a certain kind of form. Tell people, communicate what's actually happening without actually having to document it. Okay. Mm-hmm.
It seems so general that you wouldn't want to put it into the project. You would want to do the scope of the company or the scope of
Absolutely.
the project.
Yep.
Is there a way to manage that kind of thing?
So there are usually at the moment 3 ways of doing that. So one way is to write a company-wide plugin. Whenever you set up a new project, that project has to apply your plugin. Right now, there's no easy way to enforce that right now if you go that way. Go that route. The other option is init scripts. So init scripts, you put it in your Gradle home directory. It automatically applies that plugin for you. But then again, you have to ensure that that init script actually is already there for every developer in your organization. Next step would be you build a Gradle distribution. So basically, you take one version and you embed these init scripts into the Gradle distribution, which has the knowledge about all these rules here. Maybe even applies the plugin, makes these rejections and all kinds of other stuff. What you have to communicate then is to developers is that you can only use your specific in-house distribution, which has additional knowledge about how your enterprise functions internally. In the long run, we want to make this much easier. So we want a way to not having to build a Gradle distribution that you have to tell people to use. There will be something that will hook into the wrapper kind of like task. So you will be able to say, this project uses the wrapper of version 2.4, but it also automatically applies these init scripts. And then you all said if you generate that, it will already have these init scripts in the right locations, and they will be applied whenever you run the Gradle wrapper. There are other scenarios we can probably think of, but that's kind of like how we think about it at the moment, and there will be more to come, I'm sure. If you have good ideas about that, how to avoid having to create a Gradle distribution and making something work for your whole organization, let us know. We'd certainly love to hear that. But that's kind of like the approach that I usually see in organizations. Something similar to rejections is replacing legacy modules. So in this case, you could say, well, if you encounter that guy, simply replace it with a new one. Don't throw an exception. So awesome. We did the work for the user. We actually didn't fail the build. Let me show you to this example as well. And then pretty soon we'll actually get to the dependency substitutions. And in the end of the talk, I also want to show you some enterprise scenarios that we encountered and how to solve them. Some of them have out-of-the-box solutions, some of them don't. So in this case, we have these two dependencies again. And we just want to remap it in this case. So imagine you have a big dependency tree, and one of your transitive dependencies still pulls in the old one. User doesn't know anything about it. But what we can do simply by introducing these enterprise roles is that we simply remap it for you. The user doesn't even know anything about it. Sometimes it confuses people because that's not what they defined. That's certainly something that you would have to communicate somehow in your organization, because people get confused. They force certain dependency versions or something else, but then some other rule kicks in that you don't see in your own project, but it's coming from somewhere else, and that somewhere else could be like an enterprise plugin or something else. So here we use the replaced by. I believe this came in with 2.2 or something, so it's a relatively new feature.
Since you're remapping the names, wouldn't it also be possible that the same name would have different versioning scheme, so you have to create a separate role to also, remap the versions?
It's possible. I think we have it spec'd out. And this is a high-level kind of like example. There are more options, and in the long run, there are certainly more scenarios. There could be also a scenario which says, if you encounter that legacy module, actually use multiple, not just use one. We actually encountered basically a, what do you call that? A jar. Basically, it has multiple jars actually that are contained in a single jar, but we actually want to bust this up. We actually want to say, these are the new ones that I want to use. In this case, you would define not a single new coordinate, you would define multiple, including versions, which might even be different. So stuff like that. There are some plugins in the Nebula space. So if you look on the Netflix GitHub account, there's a plugin that does that as well. Okay, so Gradle dependencies, and again, you can see Gradle tells us something about it. So you see that little arrow. So the old coordinates were mapped to the new one. I'm not sure if in this example I actually also show the dependency inside report. We do, because we want to find out why this was even selected. And boom, it tells us there was some conflict resolution. It probably could have said something else, I guess, like, I don't know, remapped or something else, but that's what we picked at the moment. So this is how you can like enforce these kind of like other mappings to new versions. One more thing I want to show you, which some people requested, at least on the forum, is that artifact query API. They actually want to do something with the raw artifacts once they resolve them. And you might know that, well, the cache is opaque. So if you wanted to write any code that pulls out artifacts out of that cache, you can't really rely on the path, or you would have to adapt for each version. And that's one of the reasons why we created the artifact query API. So we want to hide the logic and abstract whatever sits on top of that. You don't need to know anything about how the cache is structured. You simply use the API for that. At the moment, you can resolve these types of artifacts. So the sources artifact, the Javadoc artifact, and the metadata. In this case, IV XML or POM XML, and then simply do something with it. How does this look like on a high level? So you have to write a bunch of more code in this case. We want to simplify this in future versions, but that's usually how it goes. You access the specific configuration. In this case, it's the compile configuration. I tried to make it easy. I broke it up into the actual assignments on what these objects actually are. Then from that configuration, we resolve the incoming resolution result, which gives us additional information about the component metadata and so on. What is the type of artifact or result? In this case, you can see we match on a specific instance of resolved dependency result. There's also a unresolved dependency result. So you could say, if I don't resolve it, then handle it in a different kind of way. And from that, we basically extract the component IDs. Component IDs are basically what identifies that specific module. Could either be a project path, or it could be like group name version usually. And from there on, we can basically use the dependency handler and build up our query. So in this case, we use the handler here. We create a new artifact resolution query. We pass in the component IDs that we've just read from the compile configuration. And then we simply specify what type of artifacts we want. So in this case, apparently, we are handling a JVM library, which applies to Java projects, to Scala projects, Groovy projects. There's an equivalent for the native space as well. So in this case, that would be a native library. And you might know that sources artifacts and Javadoc artifacts are usually fairly specific to publishing in the Java world. So in this case, we say for this JVM library with these component IDs, please give me these artifacts that you can resolve. Once you build up the query, you execute it, and you get back a result. And based on this result, you can ask for the resolved components, which then gives you direct access to the specific artifacts of a specific type that we requested in the query before. A little bit more complex. It's something that you need to get into a little bit. But once you grok it, I think if that's your use case, this is how you can easily solve it. There are some other data types for the metadata, just to give you an idea of what you need to use here. For IV, it's an IV module, and you request the IV descriptor artifact. And in Maven, it's a Maven module and a Maven POM artifact. So it's very specific to that domain, I would say. I just want to show you one example here. So let's assume we have a single dependency that we assign to the compile configuration. It's Guava in this case. And we actually want to get access to the POM XML file and want to extract some information out of it because we're interested in it for whatever reason. We want to copy it somewhere, maybe, stuff like that. So for that, we create a new task, which we can execute on whenever we need it. We create a do last action, nothing too crazy. And now we actually want to use the artifact query API. Keep in mind, these are Gradle APIs that you don't actually have to import. You're still using core APIs, but again, you don't actually have to import them. Gradle build scripts know about it. We ask the configuration named compile for the incoming resolution results. We iterate over all dependencies. So in this case, it actually gives us back a set of specific types. And we want to basically get the component IDs. So basically, of all the resolved dependencies, give me the IDs. In this case, they are component IDs. We'll actually find that there's a specific type for it as well. Again, everything is really typed. In this case, I use dev, so I don't actually assign a type. So we have 15 more minutes, so it looks like I have to speed up a little bit. So we pass in the component IDs, we get the results, and then from there on, we can basically say, hey, give me the file, or do something with that file. We could read it. In this case, in Groovy, what we want to do is use the built-in slurper functionality. So we'll actually speed this up a little bit. That's a good thing about a video. So you can see that. So we actually filter out the artifacts. So in this case, Guava, give me the POM file. That's the file that I'm looking for. Could be multiple ones. And then we use the Groovy slurper to parse specific information about the file here. And we want to print out just the name and the description of that POM file, just to make sure that we actually get it. First of all, we'll print out the location of the file on disk, so in our local cache, and the name and description. And then we run this guy. It will tell us where it is, unfortunately, apparently. Okay. So you can see that's actually sitting in the cache. That's the file that we're referencing here. And you can see that it also gives us the name and description. So if you ever have the need to do this kind of stuff, you can use the artifact query API. I actually have an even more complex example, but I'm going to jump over that. So building an offline repo, you can do that, typical use case. You want to ship a distribution of a build, and you already want to have the cache ready to go. Some organizations want to do that, or if you want to ship something to a client, you don't want to necessarily let them resolve stuff from the web or let them set up new binary repos. You can basically ship with the right structure that Gradle expects for that version, and then you're good to go. So I'm not going to show you that, but what I want to show you is what I mentioned in the beginning. I want to show you some real-world enterprise use cases. Nonetheless, all of the stuff that you've seen so far has been implemented. I've seen them in other enterprises as usually on the level of enterprise rules. But there are some other scenarios in the realm of dependency management that people try to resolve. They ask about these things every time. One of them is locking dependency versions. So let's assume you build a project and you also depend on other published modules in your organization. So you want to say, hey, I depend on library X, which is created by a different team, but they publish to a local binary repo, and Y does something else. But what I actually want to achieve here is that I want to have that constant integration pressure where I say, give me the latest released version whenever something has been released, and I want to integrate that right away into my project. So I want to pull the latest stuff all the time. Well, if you think about it, there could be potential issues with it. Well, first of all, you have to make sure your build doesn't break. So if the API has changed for that released version, you have to fix your build right away. And then also, if you publish your artifact, what happens if you need to create a bug fix for it? You might tag it in your version control system, but then you still have that latest.release in there. If you run the build half a year later, there will be new released versions and nothing works anymore. So that's obviously a bad idea. So what you want to do is you want to pin to a specific resolved version at some point of time. So doing development, you say, give me the latest release version. But then once we are ready to release, we actually want to pin down to a specific version. So you tag it, but this information has to live somewhere. How do you do that? Again, I'm going back to the Netflix guys. They have a bunch of really useful plugins. And for that, you can use the dependency lock plugin. So that actually doesn't look too different. So what you do here is you have your regular build.gradle file. You execute your build, and it pulls stuff from your binary repo. But on top of that, it also allows you to generate a so-called log file. And a log file basically says whenever you request, let's say, latest.release, it has a mapping to a concrete version. And that concrete version is the version that has been resolved at the point of time when you actually generate the log file. As you go on in your development cycle, you will want to regenerate that log file. So if you move on to the next release cycle, You want to regenerate that log file, which pulls in the latest versions of these artifacts that you depend on, and then you're good to go. So here's one example. So your build.gradle file, you don't actually have to touch. You leave it as is. You don't actually have to change the version at some point of time. And in this case, we say, give me the latest version of 14 Guava and also the latest .release from Commons Lang. Once we run a specific task of that Nebula plugin, it will generate the log file. It has a JSON structure. And you can see the same mapping here again. So we see com, Google, Guava, and these kinds of things. We see the requested version, and we see a locked version. So there's a direct mapping between these things. What the plugin does whenever you run your build and it finds that log file, it will actually use the pinned version. So if you would wipe out that file, it wouldn't know anything about it anymore. That's how it can go back. You can always regenerate that. You can create local logs for a project and a multi-project build, as well as a global log file. So that's certainly helpful. So if that's kind of like your enterprise problem, this is one way to solve this. Under the covers, what it does, it actually forces a specific version. So nothing too special. But again, it uses the flexibility of Gradle to actually make this happen. Some people asked me about a custom conflict resolution strategy. So we're coming from Maven. The way we resolve version conflicts between dependencies is different. So in Maven, we simply say, if you encounter Guava 16 and 14, simply pick the one that you find first in that dependency tree. Gradle is slightly different here. We say simply use the latest version that you find in your dependency tree because we assume there's a good reason for it. So I think that's the more useful one. But some people ask me, well, can I just implement my own strategy as part of a migration strategy, these kinds of things? Yes, you could do that. There's no built-in capability though. So it doesn't have a deep API that we want to open up really that allows you to do that stuff at the moment. But there are some ways around it, and I want to show you one way to do this. Again, you can force module versions. And here's one very simple example. So what we do here is for our Gradle build script, we simply iterate over all dependencies that we have in the build. These are all the top-level dependencies that you declared, and then simply force the specific version that we have declared, independent of what you find in the tree. So there could be a newer version, but we enforce the version that we declare in the build script. So that is something that people might want to do. I wouldn't necessarily recommend it, but you can do it. Usually it's better to train people the Gradle way, at least from my perspective, get them on board. They can look at documentation. Nothing is very special to your own organization or stuff that you do. So I think if you wanted to have something like that, try to work around it or train the team to actually get familiar with the way that Gradle does stuff. In this case, get the latest version or use the latest version in the dependency tree. So now we're finally there, switching between the binary and project dependencies. So that's also something we call fluent dependencies. And it's something that will come out with 2.5. 2.5 as an actual API. So what's the general use case? You already mentioned it. So you have a multi-project build, and you might have other modules that you have to work on as part of your regular development cycle. And you want to say, hey, in my 200 module build, multi-module build, I actually only want to touch 2 of them. But then also, if I check out the other module that I'm depending on with a module dependency, not a project dependency, I also want to touch. So I want to actually change both of these things, but they potentially live in different version control systems, so there's no good way to actually model that in Gradle. So we know that. It's something that we want to improve on over time. Right now, there are options to implement that kind of stuff. I've implemented one of the homegrown solutions for one client at some point of time. There's Prezi Pride, so the Prezi guys, they built something on top of that as well. And with 2.5, it gets even easier. So we have a low-level API to switch out projects for modules and the other way around. So how does this look like for these one-off kind of solutions? You could, again, extend the Gradle DSL with Elastic. So that's just a method name that we introduce here. If you find the checked out files or the project, then go for the project path, which would be example in this case. Otherwise, if you don't find it on local disk, assume it's an external, a module dependency. Use these coordinates instead. Prezi takes a slightly different route here. They actually introduce a completely new method, which is called dynamic dependencies, which is kind of deviates from the regular Gradle DSL, which people have to learn about and so on. So you might be able to see the problems here. But this is kind of how it looks like in Gradle 2.5. So again, we go off the configurations instance. We take the resolution strategy, and then we want to define a dependency substitution. So we either want to have a substitution from a module to a project or the other way around. What you have to define here is the group and name, as well as the project path. And again, you should have either the code checked out or not, depending on what the order is, what you want to swap out. But this is what you can do with 2.5. RC should come out pretty soon, I think in the next couple of weeks. So it's certainly in the queue here. So that's kind of like all I had for today for dependency management stuff. I will talk about a little bit more on dependency substitutions and the use case more on the higher level, I would say, or with more slides, let's put it that way, in my next talk. So if you're interested in that kind of stuff, it's happening right after. Otherwise, I would be interested in your questions, and thank you very much for being here. Hope it was helpful. Good, we cleaned out the questions right away. That's awesome. Cool, let me know if you have more questions. Just come on over.